Atlanta. I'm a senior research student in Team NRG of the Engineering Academy. In the beginning of the year, when I entered the Engineering Design and Development class with Mr. Boyer, I was completely clueless to what nanotechnology is. When I heard the term nanotechnology, I thought, oh, like the new iPod Nano? Since then, I've learned that nanotechnology is much more than a tiny iPod. In past centuries, nanotechnology was used unknowingly in the manufacturing of swords used by samurais more than 1,200 years ago. The Japanese used a method of repeated heating and folding of metal to make the katana sword, which consists of approximately 30,000 layers of metal in a single blade. Each layer measures approximately 200 nanometers thick. Also, in medieval times, nanotechnology was used for stained glass windows. As the glass was produced, gold chloride was added, causing the glass to tint to a ruby red color. This was achieved by the formation of tiny gold spheres in the glass. So as you can see, nanotechnology was utilized in the past, however, it was not understood. Today we have a greater understanding of nanotechnology because of Caltech physics professor named Richard Feynman. In 1959, Feynman gave his famous speech, "There's plenty of room at the bottom." In this speech, Feynman explained that we have so much to learn about physics and that he believes that it is possible to construct things atom by atom. Feynman then challenged the scientific community to pursue this endeavor, to design materials and devices that function at the nanoscale. Feynman was a genius who was way ahead of his time. He had the vision, but he did not have the resources to further his ideas. Like Da Vinci, who had drawings, prototypes of bikes, cars, and planes hundreds of years before they were ever conceived. Feynman had the vision to push the limits of human knowledge and understanding of physics. His ideas were revolutionary. In the scientific and engineering fields, we are now just beginning to understand the true benefits of this type of technology. We've now learned that nanotechnology actually covers a broad range of subjects, such as chemistry, materials, mechanics, and physics, with the study of controlling matter and producing functional materials on the molecular and atomic scale. When working at this scale, objects are typically measured in nanometers. So just how small is a nanometer? A nanometer is 1/billionth the size of a meter. It is so small that a single strand of hair is approximately 100,000 nanometers wide. That's pretty small. Now this image shows a red blood cell, which measures approximately 5,600 nanometers in diameter. This scanning electron microscope picture we took at Drexel University in April is a fiber from Avant-Garde. Their nanofibers measured less than 200 nanometers in diameter. By joining the two images together, keeping their scale in proper perspective, you can get an idea of just how small the fibers we created in class really are. Images like these begin to stir up thoughts about potential applications such as blood filtering and biomedical community, or maybe even water and air filtration in disaster zones, such as ones created by earthquakes and floods. This type of technology could also be used in poverty-stricken areas around the globe, where access to clean drinking water is extremely limited. When we are able to work with and reorganize matter at this scale, we're able to generate new kinds of materials, one molecule at a time. This is why nanotechnology is often referred to as molecular manufacturing. By taking raw products and rearranging their molecules, you can transform it into something completely different. This is what engineers, who are called material scientists, do. They learn how objects behave in various environments, and then they create completely new kinds by taking a good property from one and creating a new breed of materials. Today, researchers have answered Feynman's call, and now we have the ability to not only observe atomic interactions, but manipulate these atoms as well. Since this revolutionary research has been introduced, it has made its way into about every industry: automotive, electronics, clothing, sports, and manufacturing, and the medical community. Now nanotechnology research has found its way into our engineering classroom. I would now like to introduce you to another student in our class, Sarah Pearl, from Nano Sound Team. She will be discussing how manufacturing polymer fibers at this nanoscale.